Yo, what's up, guys? I know I have not posted in forever, but that's mine's that. So I have a new video series that I'm going to be starting. I'm focusing now on high school work to help those of you struggling with mathematics in high school. I'm going to be starting with functions. This video series is for people who are absolutely lost when it comes to functions. You sit in class and you don't know what the teacher is talking about. They're just yapping. You don't know at this point. So this one is going to be called the series rather is going to be called Functions from Scratch, and that is exactly what I'm going to do. I'm going to introduce functions from scratch so you can build a very solid understanding of it. Without further ado, let's jump straight into it. So what exactly is a function? Right, a function is illustrated in this graph here below, this diagram I should say rather. It is something that takes some input. We're going to use red for input, and something happens to this input. What exactly that will be specified in the type of function that is or whatever, and then it produces some output. In this case, we're going to be looking at functions like that take in some number as an input and then produce some other number as an output. And if this seems like a weird definition, let me give you an example. Let's say we have a function that just multiplies the inputs by 3. So we would have 1, we multiply 1 by 3, we get 3 as the answer. You take 2, you multiply 2 times 3, 2 times 3, everyone knows that's 6, and so on and so forth. And essentially, that is what a function is. This is one way of representing a function. And something to note with functions is that there's only one output for each input. Anyway, so since you have that basic understanding of what a function does, let's look at a graphical representation of a function, right? They can be represented in this diagram here, but let's take a look at how they are represented graphically. So let's just remove that there and take a look at this graph here. So on the x-axis, which is this horizontal axis here, this horizontal line here, we have the inputs. The inputs, just like here, they're the numbers that go into the function. And on the y-axis, we have the outputs, which are the numbers here. So if we look over here, let's say we put 1 in, right? And since this function is just multiplying, the output is equal to, let's just write it out. Output is equal to 3 times the input. So each input is just gonna, the output is just gonna be 3 times the input, right? So 1 times 3, that's 3. We draw a dotted line up there, dotted line up there until where they meet, and then we plot that point there. 2 times 3 is just 6. 3 times 3 is 9, and put a point there. 4 times 3 is 12, and we get that. What we end up getting is this array of dots, and you can join them. But let me explain why you can join them. Because this is actually also the case for every fraction in between them. So you could say, or every decimal if you want to put it like that. So 1.1, 1.2, and even the smaller decimals like 1.01, and like all the infinite number of decimals that are in between these numbers will produce all these dots here. I hope that makes sense, right? Just like how let's say you had 1.5 times 3, that would be equals to 4.5, and that would go around here. So you would end up with this. So just like that would happen with all the numbers, and so you would have an infinite number of dots actually, and those dots you can pretty much just, or those points you can join together as a line, and that line is the graphical representation of a graph. So if you were to just, this is how you may see it. You would see it like this without all the colors and dots and that stuff. This is how you may have seen it in your textbooks or what you may have seen in class. So yeah, that's essentially the graphical representation of a graph. As we said here, it can be written like this, but since we have the y-axis as the output and x-axis as the input, what we could say is y, or the input, is equal to 3 times the did I say the input? I meant the output. Is equal to 3 times the input. this is supposed to be a key. Let me just remove it because it's messy. But I hope you see that, right? That the output is just equal to 3 times. I hope you understand. This video kind of assumes that you know algebra, and that 3x means 3 times x. Yeah, so it's equal to 3 times the input. That makes sense to you? I hope that's clear. Okay, now that we've sketched this, let's take a look at what would happen if we subtracted 1 from this. So if we had y is equal to 3x minus 1, or rather let's say plus 1 for now, what would happen if we added 1 to this? So 1 times 3 is equal to 3, plus 1 is equal to 4. Let's use the correct color. 4. 2 times 3 is equal to 6, plus 1 is equal to 7. 3 times 3 is equal to 9, plus 1 is equal to 10. 4 times 3 plus 1 is equal to 12, right? Plus 1 is equal to 13. 12 plus 1. And so we end up with these numbers here as the outputs to this function here. And so let me just sketch the graph for you, the graphical representation of it for you. So we have 1 and 4, right? We put a dot there, we put a point there. 2 and 7, we put a point there. And then we have 3 and 10, put a point there. And then it should, and then I should have also added 0. So let's just imagine what would happen. 0 times 3 is equal to 0, plus 1 is equal to 1. So there's going to be 1 here, and it needs to go through that point. So let's just shift this thing, because this thing is not drawn perfectly, not drawn to scale. If I wanted a perfect drawing, if you want a perfect drawing of it, you can go to our website called desmos.com/calculator. Is it calculator or graph cal? I don't know. Desmos.com, and then go to the graph calculator, and then you'll be able to see this thing perfectly. But this is just for the video. And let's just draw the 0 here. And what we can see here is that it has essentially been shifted up by 1 unit compared to this graph. Technically, the steepness should be the same, but like I said, they're not drawn perfectly. In fact, let me just go to Desmos to show you guys. Okay, so I've gone to, yeah, I was correct. It was desmos.com/calculator. And here's a perfectly to scale sketch of the two graphs. And this is y is equal to 3x, the red one. And the blue one is y equals to 3x plus 1. As you can see, it's shifted up by exactly 1 unit. How do we know it's shifted up by exactly 1 unit? We see that the difference between the 0x value to the 0x value to the other one is exactly 1. Okay, and now let's try to sketch this thing as y is equal to 3. I'm doing all the parts that don't require the color first. 3x minus 1. To see what happens in this scenario where we subtract from this original part that we had. Because if you remember, the original just went through this, to call the origin. And then this one was shifted exactly 1 up, as you remember from the Desmos sketch. And let me just draw this diagram out for you guys quickly. Okay, so here's a diagram, like the basic diagram of the function. By the way, this diagram, like if you're in high school, I don't have to do this thing in high school. So this is just for demonstration purpose, just to make it really clear what's happening to each number. Yeah, because I don't want to confuse anyone. I don't want anyone to get to the end of this video and ask themselves, what exactly did I just watch? So here is the graph. Oh my goodness, I forgot to select. I forgot to select some. Okay, let me just select this thing here. Select everything, then drag it up properly. There we go. And I'm not going to go through the whole sketching process again, but I'm going to show you 1 lines up with 2, 0 lines up with -1, 2 lines up with 5, 3 lines up with 8. And as we see, this one shifted 1 unit down compared to the original graph. So what does this teach us? What does this teach us? It teaches us that in an equation, let's just choose any number, let's just say 3. Whatever you add or subtract here shifts the graph for straight lines specifically. Let's say for straight lines, shifts the graph 1 unit up or 1 unit down. Actually, this isn't only true for straight lines, but for now we're gonna say for straight lines, it shifted not 1 unit up, the equivalent number of units up. So let me show you guys in Desmos. Okay, we're back in Desmos. Here are the 3 graphs. You see them with their corresponding colors. So here's the one that we just drew that shifted 1 down. Now let's say, for example, we had y was equal to 3 x minus 5, for example. You see then it shifts 5 units down. And also what you may have noticed is that for straight lines, this number here, the number that is at the end, is the same as the number that is on the y-axis. As you notice here, it intercepts, which means it crosses the y-intercept at -5, yo. And then yeah, okay, let's go back. Actually, let's try a few more things. +5, let's say +5. See, confirms our suspicions. +10. Yep, just as we thought it done. Now we're back here. And so there's a general expression, right? The general term is just plus c, where c is some constant number, meaning it's not a variable, it's just some constant. Some people may also say plus q, whatever. Any letter of the alphabet could be used technically to denote that, but we generally accept like y or x because they're already used to represent something. But the usual way in which we represent it is with a c or with a q, plus q. And it's specifically a plus because if c is a negative number, then the negative will multiply with a positive and then become a negative. Like let's say it's -3, then it becomes -3. But if it's +3, then it becomes still +3. But let's say it was -3, or let's say it's minus c, and you wanted to shift the graph down, and you say you say c equals to -2, then this would end up being y is equal to 3x minus -2, and then that would be 3x plus 2. You see, that's why it's just plus, because plus is, in my mind, plus is like less power. Let's say it will lose in a battle to minus, so that's why it's plus. And let's then look at sketching these graphs. We'll get to what a slope or gradient is later. I literally recorded a part where I was trying to explain it, and I had no idea how to explain it. So let's first get to sketching of these graphs. I should probably say sketching straight line graphs. But yeah, I'm looking at my handwriting, and you can clearly tell I haven't written in quite a while. Let's say we are given some formula, because this is the formula expression of a function. Y is equal to 4x. I know we've been seeing 3 the whole time here. The 3, it does not actually matter. Plus c, or like, let's not say c. We want to get an actual number. We want to have actual numbers so we can sketch it. So it's just like with the previous things. It's just a function. But I'm going to teach you the way that you're actually supposed to go about sketching a function, instead of finding a few random points and then joining them together. So what you want to do is you want to find where the function would intercept the x-axis, known as an x-intercept, and where the function intercepts the y-axis. Then with straight lines, you can just join those 2 points and bada bing, bada boom, you've got your line. Assuming that it doesn't just go through the origin. But the way you go about finding x-intercepts, or x-ints for short, or y-ints, is by making the other one equal to 0. So let me show you what I mean. Let's say I wanted to go about finding the y-intercept. So to find the y-intercept, you say make x equal to 0. So over here we want to make x equal to 0. So we want to say, let's bring back the color. Y is equal to 0 times x. No, my goodness. I meant 4 times 0. Yeah, because x is 0. Plus 1. 4 times 0, that's just 0. Plus 1. And that's just equal to 1. So that means that the y-intercept is going to be at y is equal to 1. Right? I hope that makes sense. And if you remember in the last part, we said that we don't technically need to go through this whole step, but you know how math teachers are, you have to show every single step. So I should actually put that there, because some math teachers might be pedantic. I like to make fun of the pedantic teachers. For those of you who don't know what pedantic means, Google it. I don't know how to spell it. Like I said in the previous part, you can just look at this here. You can just look at this, and this will actually tell you what the y-intercept is. But in case you forget that you can look at that, you just make x 0. Why do you make x 0? I'll explain that in a moment. But for now, let's just look at how to find the x-intercept. Remember, as what I said, the easy way to remember this is you make the opposite one of what you're looking for 0. Make y, it just broke the rule that I just told you guys. Imagine. So we want to make y equal to 0 in this case. Let's add a bit of color, man. This, you know what inspired me to use colors? It's the Khan Academy videos. Organic chemistry tutor, his videos are cool. They got colors too. So you say 0. Why did I make... No, I swapped the color. It doesn't even matter, bro. So I'm going to say 0 is equal to 4 times x. 4 times x, 4x. Like I said, I assume that you guys have some understanding of algebra, so you should be able to solve this. So you just subtract 1 from both sides. You're going to end up with minus 1, 4x. Then you divide both sides by 4. And what you end up with is negative 1 over 4 is equal to x. Now that's quite an ugly number, yeah, given whatever. But that is the answer. And so what we do is you put this onto a graph. Like we said, the x-int, y-int, y equals to, what did we, not 0, y is equal to 1, my bad. I really want to do things in colors because the colors make it look nice and visually appealing, I don't like looking at boring things, me personally. I don't like looking at boring things. I'm just yapping to myself while writing this. You know what I should have done? I should have paused the recording. But it is what it is. I'm already done now. So here we've got a graph. We've got the x-axis. We've got the y-axis. So we just say, you can do this with a ruler or whatever. I don't have a ruler. So you just say 1, negative 1 over 4. Also, this series also assumes you understand negative numbers. And yeah, you join those and then you get the line. You just put your arrows to indicate which way it's going, and that's pretty much it. That is your graph sketched. Let's do another example. I'm gonna keep on doing examples because examples really help you understand it. But yeah, let's try one where this number over here is negative. Y is equal to negative x. we're just gonna say y equals to negative x. Let's just see what happens in that scenario. Y is equal to x negative. Okay, so what we immediately notice is that based on the trick I told you, there's no, we're adding 0. So in this case, it's just going to go straight through the origin. But all the graphs that you guys have seen so far have all been going in that general direction, right? They've all been going like that. But in this case, because of this negative that we have over here, what's going to happen is the graph is actually going to go downwards. And watch this. So let's go through the same steps. Let's go through the same steps. Y-intercept. We want to find the y-intercept. Oh my goodness! I just realized I may have been writing a bit too small. Hopefully, it's visible on you guys' screens if you're watching this on a phone. Cause let me tell you guys, while I'm busy writing this thing, we used to sit outside the exam venues, and just before the exam, we would watch a guy named Kevin Math Science, who, in my eyes, is the coach of South African maths videos. Yeah, just before we'd watch that thing on 2 times speed, wishing there was a 4 times speed. But yeah, anyway, so what we see here is that y is equal, we make x equal to 0, y is equal to negative 0, but negative 0 is just 0, so we end up with y is equal to 0. And then for the x-intercept, let's do this to save space. For the x-intercept, we're going to say, remember, we make the opposite one equal to 0. So it's going to be 0 is equal to negative x. And same thing is going to happen here. You multiply both sides by negative 1 times negative 1 times negative 1, so that the negatives will cancel and give us a positive. X is equal to 0. Yeah, and so what you notice is that the intercepts are both going to be 0, right? Just as we predicted, it's going to go through the origin. But now we need to know, like, how is it going to look? So in this case, when you have 2 going through the origin, we're just going to pick like a random x value. Is equal to 3. So that means that when x is 3, what will the y value be? That rhymes. I'm a poet. Bet you all don't know William Shakespeare was a poet. Anyway, I say anyway a lot. What the heck? Then we got this graph here, and you see it's negative 3. So with the straight line graph, all you need is 2 points. Then you can connect the 2 points and then have the graph. So remember, we know that the 1 point, there's a point where it goes through the origin. And then now we have 3 as the x point and negative 3 as the y point. So we have 3 and then negative 3. Like I told you guys, it's going to be in this direction this time. Minus the fact. Minus equals ignore. If I say minus, it means ignore. Minus the fact that it didn't do that properly. It didn't go through the thought. Minus is South African slang. That's not a mathematical term. You don't gotta jot that down in your books. Don't do that. Yeah. So as you see, it has this negative direction, and that is because of this here. And that brings us to what I've been building up to, essentially, which is the concept of a slope, or otherwise known as a gradient. In my school, we called it a gradient when I was in high school. Yeah, and then I know Americans and other folks call it a slope. In uni, you call it, I think both terms are interchangeable, I don't know. We just use like slope most of the time. So the slope refers to, let's bring back the colors, y is equal to mx plus c. Remember, for the c, we had, for this thing that shifts the graph up and down, we had this general term. And now for the slope, we also have a general letter, which is this m. And I know The C is interchangeable with the Q in some places, but I'm pretty sure in most places we use M. Everyone uses M to refer to the slope or gradient. So the gradient or slope just refers to how steep the line is, or whether it's going upwards or downwards. Yeah, and through a lot of practicing, you'll get a feel for what kind of slopes are big and which ones are small. And yeah, but I think I'm just gonna make another video on sketching graphs. That's all for this video. I think I've covered everything that I wanted to cover. Let me just take a look at my notes. Yeah, that's everything I wanted to cover. Thank you guys for watching this video, and stay tuned for the next one.